Okay, so I just wanted to share an activity that I like to do when I was teaching in the public schools, and I think that maybe you could use this as well when you're teaching geometry. It's using the notions of geometry using Play-Doh. So I just wanted to show you how this would work. First off, I want to share some classroom tips. If you're planning out Play-Doh or any other manipulative, make sure you go through proper and improper use of the Play-Doh, explain any classroom rules or boundaries with the Play-Doh, and then explain how the Play-Doh will be distributed and collected and how long the Play-Doh will be available. I know this seems like maybe not that important, but it sure is going to save you a lot of headache in the long run. So the first thing we're going to do is create a point, line, and plane with the Play-Doh. So here I have some Play-Doh. So we have a point and we have a line, and then you ask your students to make a plane out of that, and then you can say, so this is the plane, this is the point, and this is the line. Then you can say, okay, put 2 points on your line, and then so they can actually see what a point, line, and plane is. Next, I'd ask them how to create the following with Play-Doh: a ray, a line segment, and an angle. Okay, so here I've created a ray. Make sure that when you have a ray, you need to have the arrow on one end of the ray. A line segment, be sure to emphasize that you need endpoints on that one because that doesn't keep going, it stops. And then for the angle, a lot of students would create the angle kind of like this. But remember, an angle, by definition, is two rays with the same endpoint. So rays have to have arrows, so make sure you keep your arrows for your angles. The next one we'll talk about is parallel, perpendicular, and skew lines. So for parallel lines, you just take 2 lines and make sure that they're holding them here, or technically they could be above each other like this, or they could be on the table, but just make sure that they don't cross. Perpendicular lines would be 2 lines that cross with a 90-degree angle like this. And then skew lines. This is one that's really helpful to have the Play-Doh in your hands. So skew lines are 2 lines that are not parallel, but that won't meet. So for example, you could hold one down here and one above it at like a right angle, kind of like one edge on the floor and another like the corner between the floor and the wall, and a perpendicular line between the ceiling and a perpendicular wall. These aren't parallel yet, they won't ever meet. So having these physically really helps them to understand what a skew line is. Next, we have collinear points, coplanar points, and coplanar lines. So for collinear points, you have 3 points that all line up. Any 2 points, if you have any 2 points here on in the space, they're always going to be collinear because you can always draw a line through them. If you have 3 points, then they might not all be collinear if they were not all in a line. So be collinear, this would be non-collinear points. Coplanar points means they're all in the same plane. So if you take some points and put them all on the table, they're all in the same plane. Or you could make a vertical plane by holding these above them, and the plane would be like up. So this physical manipulation of the Play-Doh really helps the students understand what those are. And then coplanar lines would be 2 lines in the same plane, whether or not they cross or if they're perpendicular. If they're all on the table, they're all in the same plane. Or you could hold them up and they're still in the same plane. But if you put one down and one up, then that is not necessarily in the same plane. That is actually not in the same plane. Unless you hold it on top of each other, then they will be in the same plane. So having these physical objects helps the students understand the definitions of these collinear points, coplanar points, and coplanar lines. Next, we're going to be asked to show how 3 lines can interact. 3 ways lines can interact with lines. So you have parallel, You can have perpendicular and or anything intersecting really. So you have parallel in the same plane. You can have intersecting in the same plane. And then the other way you can have is skew. Skew lines would be two lines that are neither parallel but will never connect because they're in different planes. Show 3 ways that lines can interact with planes. So let's say we have a plane here. We can have a line inside a plane. We can have a line going through a plane, so like intersecting a plane. So you have a line coming through the plane, or you can have a line parallel to the plane and not ever touching the plane. So those are 3 ways that lines can interact with planes. Next, we're going to show 2 ways planes can interact with planes. So we have 2 planes, which kind of just look like pancakes right now. So I have 2 planes. 2 planes could be parallel. So one could be down here and one could be up there. So they could be parallel planes, or they could be intersecting planes. Now students like this one because you get to rip up your plane and like stick your plane like this so that you have kind of like a T shape. So this is a plane intersecting another plane. And so having that really helps them to understand what 2 planes intersecting is. Next, we want to discuss how any two points can define a line. So if you have 2 points here, no matter where you place them, you can make a line through those 2 points, no matter where it is in the room. And you can be silly and be like, okay, what if you put 1 point on the top of your nose and 1 point on the top of my toe? Would that make a line? Yes, it would, because you can create a line through space to any 2 points, and they like that one, and you can be really silly with that one. Any 3 non-collinear points define a plane. So we have 3 points right here. Obviously the plane is the table because they're all sitting on the table. Okay, but if I pick one up, then that still defines a plane. Any 3 non-collinear points can define a plane. It's just cutting through the air at an angle. No matter how I move them, I can still create a plane through the air. And so that's kind of a hard concept for students to understand, but when they start moving these 3 points around and you're like, well, these don't make a plane, well then you're like, yes they do. And so you can challenge them to try to find 3 non-collinear points that don't define a plane, and you can show them every single choice that they make is going to define a plane. It's always going to cut some way through to create a plane. And so that concludes my examples of Play-Doh using the geometry with Play-Doh, but you can come up with, I'm sure, a lot of other interesting techniques using Play-Doh, and I just thought I'd share those. Hope that helps you in your future classrooms.